Hi, good evening, and welcome to my daily live session on various topics. My name is Dinakar. I am the founder of Samuthana and the inventor of Do How, a methodology for driving teams to achieve challenging goals and amazing outcomes while getting them to acquire leadership skills, which is all about people and doing the right thing by changing their mindset and culture, and management skills, which is all about systems doing the thing right by progressing on the journey towards smart manufacturing. So that's the basic value proposition that we bring to the table. With that very brief introduction, let me invite you to write an email to me if you want to know more about what we do. Dinakar@samutana.com is my email address, or you can also visit our website. Dinakarmurthy.com is the website. So, with that very brief introduction, let me jump into the topic of the day, which is to talk about smart manufacturing process cycle. I've been telling that there are multiple cycles in smart manufacturing. I started by talking about the fundamental concept of control, which wherein you have got a control phase, which is talking about trying to get an algorithm in place, and then based on the algorithm or based on the plan, you would actuate or do the job. Actually, actuating is nothing other than doing, and then sense the progress by checking the status. That is what happens in the third phase, and the fourth phase is to correct it. That is the acting phase, where the algorithm gets corrected, gets adopted to make sure that the actuation is much more precise. So these are the four phases, and these four phases is a standard thing in any PDCA cycle or the plan do check act cycle. It's a very simple mechanism. There is nothing so what should I say complex about it, and the smart manufacturing, I said I would like to talk about showing smart manufacturing in these seven cycles: product cycle, process cycle, people, performance, productivity, programming, and progression cycle. And today we are going to be talking about the process cycle and the second phase of the process cycle, which is to develop the product. That is the next phase of the process cycle, which is product development, process development, and that's what the activity today would be. Yesterday I spoke about the the process design cycle, the design phase, where we are creating a value stream and splitting the main set of operations into smaller bits and pieces. And now we need to really develop these bits and pieces of processes which have been defined in the value stream. So here there are multiple activities to be done. I'll talk about smartness in all these areas. First is fixture tooling, gauging, and consumables design, or basically specifications design. Here, a lot of database management could be used. Not much smartness, but database management and smart nomenclature. That is something which is very key. So that from the existing indirect material stores, one could easily pick up those materials, those tools, those fixtures which can be used without any problem at all, because there is a standard nomenclature. I remember when I joined Myco, we had nomenclature where the BA stood for simple drills, and R, I think reamer normal RN or RA stood for a normal reamer. So moment I saw the number, which was an alphanumeric number, I could recognize what kind of a tool I'm talking about or what kind of a fixture I'm trying to look at. Whereas as the days progressed and SAP came into existence, all that vanished, and then now it's only a 10-digit number. God only knows what that number means. There is no real way to interrelate. So therefore, whether it is SAP or any kind of a ERP, it's mandatory that you have some kind of a logic for defining tools, fixtures, and gauges. And by doing that, it's a phenomenal way of using artificial intelligence to really pick and tell you what kind of tools can be used, because there is a nomenclature which is available. Otherwise, it's difficult to search the databases. That is the first area where smartness can be built in. Second is in terms of material handling and flow. That is something which is extremely critical, especially in manufacturing, where the components are counted. That's really the biggest offense that anybody can do in industry. Every time you count, there are a lot of mistakes possible, and the components get damaged, and the injuries occur because of counting, and the number of parts get interchanged. So many things will happen. So that's a kind of a devil in the in the manufacturing. So to avoid the counting, one needs to look at how do you do the material handling and how can it be ensured that the primary, tertiary, and primary, secondary, and tertiary packaging is so designed that there is no need for any counting at all. That means you just pick up the material which came and then remove the packet, secondary packaging, then remove the secondary packaging, primary packaging, and that primary packaging directly you supply to the workstation where the assembly will be done or where the consumption will be done for that particular material. And that's the ideal way of doing it. To do that, a lot of simulation is required, a lot of what should I say, design is required, and that can be done using computers. That's the way smartness can be brought in. And if that one problem is solved, my dear ladies and gentlemen, then it will be a magic in manufacturing industry. If I go to any factory, you see material laying everywhere, and the handling is really awful, and a lot of damages and a lot of rust getting formed. Multiple problems are there, and oil getting dirty, dust getting collected. That leads to a lot of problems on the machine. Multiple reasons, and the entire thing looks really dirty, so it's not really the right way of doing it, and there computers can really be of a great help. The next one where it can be really useful is the process and the flow simulation. I remember, I want to tell you a story. Sometime in 1996 it was, I think, yeah, 1996. I had just then come from Brazil. I was in Bosch, Brazil till 1995, then came to Bangalore in 1996, wherein I was doing some kind of various projects, and my job was business reengineering. And one of the ones which I was excited in 1996 was theory of constraints. So I went all the way to UK. When I had gone to Germany, there was some other job for which I had to go to Germany in 1996. I think it was a pre-visit for my assignment, and then it was some kind of an interview and pre-visit. And during that time, after that, I went to England and went to the headquarters of Goldratt Consulting in England. It was close to London. Don't remember the name of the city. It's a small city. And there we went and spoke to them. And after that, I bought a simulation software. And that was fantastic. Have you heard of drum buffer rope method? If you go through my videos in YouTube, you can see that. And that's one of the videos which I have spoken about the tool for scheduling and managing a shop floor. A fantastic tool. And that drum buffer rope method simulation was available in 1996 on a floppy disk. I think each of you remember. It's a small, about 2.5 inches through 2/4 of an inch, 2 3/4 of an inch size a disk, or 3 inches. I don't know what, or 4 inches maybe it was. So that disk had this process flow simulation where you have to basically define the processes and then define the cycle times and the setup times, and it would simulate as to how the inventory would get built up. And today there are phenomenal tools where you can simulate the entire process in a very, very, what should I say, realistic way. And that process flow simulation itself is huge smartness in manufacturing, because you could predict what is going to happen at a later date based on the data. And this entire thing, once it is linked back to the direct data coming from SAP. Now again, I'm talking about something which is a little high end. You have done a process simulation using the static data which was fed in, and later replace the static data from the live dynamic data coming from the ERP system, be it SAP, be it Oracle or Infor, and then you are in a position to simulate your entire process flow with a digital twin. I'm using some words which possibly are more common, more comfortable for the new age digital guys. Digital twin is nothing other than a parallel system which you have built on the computer, which is identical to the live setup, and that's the core essence of artificial intelligence. Only if you have a digital twin will you be in a position to do prediction, and that can be done using this process flow simulation concept which I explained. That's something which we have done, and I would be more than happy to talk about that if anybody is interested. Then the next is the process parameters and the sequence. This is something which is very interesting. Me and another friend of mine who runs a factory in the aerospace industry, we were working on that. I don't know what the status is. I need to check up with him, which I will do one of these days. Where imagine a situation where you pick up a component and digitize that, and once you have digitized it, the component then your system then identifies what is the best path the tool can take for machining that component. That means it is defining the tool path, which is already possible. You got SolidWorks, for example, which does that, where you can get a CNC program done based on the sequence defined. And here you're talking about defining the process parameters and the sequence, everything on the computer, so that it will pick up the tool, because you've got the fixtures, tools, and gauging and consumables are all available in the stores, and that is all coded so that nomenclature is easy to understand, easy to pick it up. So it would pick up the tools, then define the process flow and throw out a program for the machining to happen, either on a VMC or a HMC or a turn mill center. And that is something which can be automated. That's the second area which we were working. And in my roles in Germany, it was done. In some cases, it was already implemented within Bosch. But right now, anyway, I can't talk about that. But there are a lot of places, and I think, see, coding is not a problem. Coding is possibly the least issue. The bigger challenge is to understand the logic. I keep telling that when you look at the control cycle, there are four phases: control, then actuate, sense, and correct. The control is the key phase, where that's the planning phase, where you're really defining what the algorithm is, and that algorithm definition is what I know, and coding can be done by anybody else, and that's another area where we can think of smart manufacturing. So thanks a lot for watching. Please do comment. Please do give your impressions and feedback. And so today I spoke about the process development, and tomorrow I'll go to the next phase, which is the check phase of process cycle, which is what? Let us see. Which is to ensure that stability, capability, and flow is available in the manufacturing. And I'll talk about that tomorrow, more or less at the same time, 8:30. Today I got pretty delayed because of a call which I had with some of the project interns. So sorry for that. And youngsters are very excited, more than excited. I'm really impressed, and what should I say, astonished with their ability to look at the problem holistically. That's something phenomenal. At that age, I never had that ability, and the amount of knowledge they have got is outstanding. Whatever you explain, and the guys can capture it and grasp it very, very quickly. I never imagined when I would go as a trainee, the superior would explain to me 10 times, and maybe many times I would not even understand what he's telling, because there was a big gap. And today we talk about gap between industry and academia. I feel it's not the gap that is the problem. The problem is the industry expects everybody to work, or let's say it has an intention of getting people to think, but would wish that everybody work like bulldogs without really thinking, because every industry has a very high process maturity. So nothing much to think. Moment you think, you are disrupting the apple cart. So better not to think. Only work, follow orders, and that is not something these guys are good at. You give them the purpose, tell them this is what you need to do, and the amount of competence these guys have is phenomenal. So that's what excites me. So thanks a lot for watching. See you tomorrow, more or less at the same time, 8:30 Indian Standard Time, on the next topic of stability, capability, and flow for process cycles. Thank you, and good night.